Hello, Year 8. Okay, so with the constructions, I think I'm still awaiting some answers just to see what's going on, but I'm just going to pause it for a little while and we are going to continue looking at the angles. I will come back to the constructions. Can you just make sure that you answer on where I've put the question on the actual stream to ask whether you've actually got all your construction equipment? If everyone has all their construction equipment, I will just carry on with the construction lesson. If not, I just know to postpone it until we can find a time when everyone can just go grab a kit and then they can do what they need to. Okay, so in the meantime, we're just going to start looking at quadrilaterals, as you can see. So I've got loads of different types of quadrilaterals. We're just going to jump straight in. You need to be making a diagram on all of these and writing down the properties. You might want to draw on the actual diagrams to show the properties. So sometimes it's easier to draw, sometimes it's easier to write them down. I personally prefer drawing. All of you guys know I like my drawings and my diagrams. So I'm going to draw them because I find it's much easier than writing stuff down. It's much easier to say a square has 4 equal sides on a diagram than it is to write down that whole sentence. Okay, so if you want to pause right now, make sure you take down the shapes. I'm just going to work through the shapes one at a time. So if you want to draw a square, try and write stuff down, then we'll go through the answer, then pause, draw the rectangle, and then continue doing the same. I will just be working through them like this. So if you want to pause at each stage, that's fine. If you just go, oh, well, I know all the answers, then obviously I'm expecting you to draw all of them, write down every single property that there is, forward to the point in time where I've completed the whole sheet, and make sure that you've got all those notes on your wonderful sheet as well. Okay, so I'm just going to get on with this. So you'll probably notice I've got the worksheet on there. This is one of the worksheets that I've popped on where you can actually test out all the knowledge that you do and do not have. Okay, so that will be on the classroom for you to complete in your own time. But in the meantime, I'm going to go for this. And we're going to start going through them. So the first one, obviously 4 equal sides, 4 right angles. So I'm going to say it is a regular shape. If anyone wants to know, it means it has equal sides and equal angles. That is a regular shape. So this is my square. I think all of you knew it was a square. Okay, another way to write down equal sides is to just have those lines. If I have those lines, that means all of them are of equal magnitude or equal size. Okay, another thing that I would know is, I'm going to put this in a different pen colour actually. Okay, so we also have parallel lines on a square. So this one is parallel to this one. I'm going to have 1 arrow at the top and bottom to show that these 2 lines are parallel to each other. For this one, I'm just going to have 2 arrows because these 2 are parallel to each other. However, they are not parallel to the one that only has 1 arrow. So depending on however many sets of parallel lines, the first one I would probably put 1 arrow, the second one I put a lot of 2 arrows, the third one 3 arrows, so on and so forth. Okay, so I've got 2 sets of parallel lines currently showing on there. I've got my equal lengths. Am I missing anything? I ponder. So I am currently missing the lines of reflection. So I'm just going to pop them on. I'm just going to use my red pen. Oh, actually, maybe I'll just use a pencil. Should I use a pencil? I have a pencil. Let's use a pencil. Okay, 1 line of reflection or symmetry in this case. Got a second line of symmetry, a third line, and a fourth line. Okay, so you've got 4 lines of symmetry. So regular shapes will always have the same number of lines as they do sides. So if I have an equilateral triangle, I have 3 lines of symmetry. A square, 4 lines of symmetry. A regular pentagon, 5 lines of symmetry. Regular hexagon, 6 lines of symmetry. And you just keep going down the list, okay? So I've got 4 lines of symmetry. I have 4 right angles. I have 2 sets of parallel sides. I have 4 equal sides. That is essentially your square. So if you wrote all of that down, huzzah! If you didn't, note it down, okay? I've not written all the notes because I've popped all the notation onto this diagram. So for me, that works. If you kind of look at this diagram and that's the first time you've seen the set of parallel lines, that's the first time you've seen lines of equal length, please ensure you write the notes just to make sure that you've got enough notes in your book. So next time you look at it, you won't just go, what does that mean? Okay, so you should be able to write enough notes to be able to do it. Okay, the next one is a rectangle. Okay, so we're going to look through and try and see if we can find the same properties on there as well. So I'll have one set of lines there, equal length, and these are also equal length. Okay? So is that when I'm looking at the parallel, I'm essentially looking at my square to try and see what other properties I can bring out. So I've got two sets of parallel lines again. So I've got the parallel lines. Ooh, the right angles. I have right angles. Okay, in terms of lines of symmetry, if I go and get a rectangle and I try and fold it, it will not reflect. So a lot of people seem to think there are lines of symmetry in a rectangle. There are not. Well, not in the diagonals anyway, sorry. So just want to run it through with you guys. This is a rectangle. So I've drawn, well, I haven't drawn, I folded a line as a rectangle. So if it was a line of symmetry, when I fold this together, this corner and this corner should meet because I shouldn't be able to see the other side. When you fold it through a line of symmetry, you just won't be able to see the other side. You're folding something in half. So is that a line of symmetry? No, because I can clearly see that part, okay? A line of symmetry is where I am folding it and I know it's a mirror image because they're so reflected that I can't see the one below it. So yeah, some of you may notice this is a pin sheet. I do take stuff home because I mark books at home every once in a while. Obviously can't do that right now, but it's all good. So here's my rectangular piece of paper, folded in half. Can I see the bottom? No, I folded it. I look at it and I go, well, if I had it on that side, I couldn't see the other one and I can't see it that side. I folded this exactly in half, okay? So when you're talking about those lines of symmetry in a rectangle, the diagonals just won't work for it. Okay, but there is a line of symmetry down this center and there's also a line of symmetry down at the center of this side. Okay, so I've got two lines of symmetry, four right angles, two sets of parallel lines, two sets of equal size lines, and that would be my rectangle. Next shape, if you can recognize it. Dun, dun, dun. Not the diamond. I can hear a few of you saying diamond. It's not the diamond, it's a rhombus. Okay, so when I'm looking at this, hey, I'll just look at the square again. I'll say for a rhombus, all sides will be equal. So I know that. Do they have right angles? No. Can I get two sets of parallel lines? Yes, I still have two sets of parallel lines. Can I get lines of symmetry? So the rhombus is an interesting one. There are lines of symmetry. And it's the diagonals. Pen keeps making sounds. That's not a pen, it's a pencil. Oh, Tamina. Okay, so in regards to that, that's my rhombus, that's my two lines of symmetry. You will notice that just like the square, they do actually meet at right angles. So whereas in the square, people don't really acknowledge that the diagonals meet at right angles, in a rhombus, it's quite well known. It's one of the big things they usually use in problem solving questions. They usually talk about, so most people know about the square because it's a nice easy one, but with the rhombus some people seem to forget it does meet at right angles, or the diagonals are perpendicular if you wish to make sure it was all nice and technical so you can talk about perpendicular lines there. Yay! Okay, next one. Is there anything else? So I've done those lines. Oh, there is one more thing about this fabulous thing. Does anyone know what that would be? I ponder. Bonus points to anyone that knows this. So when it comes to a rhombus, the opposite angles are equal. So if, I'm just going to call that, if that was angle A, then that means this is also angle A. Okay? And if that's angle B, then yes, as someone has probably just said to the computer, this is also angle B. Okay, so opposite angles in a rhombus are equal. So I've just drawn it on here as a diagram, but obviously if you need to write that down as a note, please make sure you do so. So opposite sides in a rhombus are equal. Okay, the next one. Dun, dun, dun. Parallelogram. Okay, so equal sides. Well, this one and this one are equal. This one and this one are equal. Okay, this one's equal to that one's equal to that one. Diagonals, we're not going to do. This, just like the rhombus, has exactly the same rules. So this would be angle A, this would be angle A. So the opposite angles in a parallelogram are also equal. Okay, so if I said this was 130, that one I know is automatically 130 if it is a parallelogram. Is there anything else? Nope. Okay, anyone know what this is called? 4-letter word, starts with K. Kite. I think there's a bird called Kite as well. But anyway, I digress. So for the kite, some of you may recognize some of the properties. If I drew a line of symmetry down here, because there is a line of symmetry in a kite, would you be able to pick up on any new facts? I ponder. Okay, so these two sides will be equal. These two will also be equal. Okay, so you have two sides of equal length. In terms of the angles, these two, because it's a reflection, these two are equal. So if I call that A, that's called A. So you should just be aware of that. Okay, don't have any parallel sides. I've got my line of symmetry. I've spoken about the angles, and you should be fine. And that is your kite. Okay, this one is a very interesting shape because there are several different names that people know it by. So sometimes it's called an inverted kite, which might give you big hints as to what properties this has. A delta, arrowhead, or a chevron. Okay, I don't know if there's any more names, but these are all the names I've usually heard for it. I think I've only really seen that a couple of times. I think I've seen that once, and I usually see something across these two. But you never know, so you should be aware that all of them stand for that. In the same way that this one has two different names. Okay, so it's perfectly fine. So when you see that inverted kite, you should automatically be able to see what properties that it has. So you should be able to say, well, if that's got a line of symmetry, this must have a line of symmetry. If that angle is A, then this angle must also be A. And these two sides are the same, but these two sides are also the same. Okay, so that's what they have. Okay, for these four, this one I'm just going to give you straight away because it's not really related, but it is important to just realize a four-sided shape is called a quadrilateral. Sometimes they won't have anything, they'll just give you a random quadrilateral, and you need to be aware of that. because some people seem to be the impression that all quadrilaterals must be special. Well, no. Some are just quadrilaterals and that's it. It's got 4 sides, place them together, got a quadrilateral. Okay, so that one's just like the one you need to be aware of. There's nothing about lines of symmetry or anything else with it. Okay, so these 3 all have the same grouping. These 2 are special versions of this one. Okay, so otherwise you would have said trapezium, or you would have stated trapezoid. Under the IGCSE, we usually see trapezium, not trapezoid, okay? But most people are aware of both, so if you're relating to either or, that is perfectly fine. But just be aware that trapezium is probably the word that people will use in exams. They won't necessarily use trapezoid. Okay, so the only property that a trapezium has is that it has one set of parallel sides. Okay, it's the only thing that all trapeziums have, one set of parallel sides. So this is a trapezium, that is, and that is. That's how you know it's a trapezium, because it's only got one set of parallel sides. If there were 2 sets of parallel sides, it would otherwise be a square, a rectangle, a rhombus, or a parallelogram. But it doesn't have 2 sets of parallel sides, only has one, so then it becomes a trapezium. But even within that, you have special types of trapezium. So for this one, this is called a right-angled trapezium. Why, you might ask? Because there's right angles. I know. Okay, for this one, you may notice that it looks symmetrical. This is an isosceles trapezium. Okay, and there is a line of symmetry just down the center. Okay, but because of that line of symmetry, all of a sudden I can start saying stuff like, well, if this is A, this is A. If this is B, this is B. And if anyone is thinking ahead, you might notice it's a set of parallel lines. So co-interior, just in case anyone noticed that. Okay. So this is your set of special quadrilaterals. You need to be aware of these special quadrilaterals and how you can use them. So if you are looking, there is a sheet. It does say triangles and special quadrilaterals. So you should already know about, say, like F, which is your equilateral triangle, which has 3 equal sides, 3 equal angles. G, which is your isosceles triangle, obviously 2 equal sides, 2 equal base angles, 1 line of symmetry. And you have H, scaling. Everyone knows the scaling, okay? So that sheet is all about the special quadrilaterals, but we do also want you looking at some sort of angle work. So if you just hold on a mo, and I will magically switch the screen to angles. So just looking across over there, you should be able to notice that there are angle problems, and all you need to do is just try and see if you can work them out. I'm just going to sketch them here because I don't have a printer at home, so I just need to sketch them on pieces of paper. So it says angle problems. I'll work through a couple of them, but I would expect you to be able to do them by yourself. Work through a couple? Yeah, if I work through one question, there's 3 there, so that's fine. I'll work through the first question. So you got 1. First thing you need to do is say, is this a special quadrilateral? They've already told you that it is a parallelogram. So what do I know about parallelograms? Parallelograms? Dun, dun, dun. Okay, so if this is 124, obviously pause this if you're going to do it by yourself, and then try it, and then unpause, and then we'll go through the answer. Awesome. Okay, so you've got 124 degrees there, so opposite it will obviously be equal, so you've got 124, and then I did tell you that it is a co-interior because they are parallel lines. You should remember they are parallel lines, and so they are co-interior angles. You could use quadrilateral, angles in a quadrilateral add up to 360. and then just add those two together, take it away from the difference of 360, then get the difference and divide by 2, which is a perfectly valid method. Quite a few people do that. Personally, everyone knows I like to go for the shortest route possible. So co-interior angles, that's 124. So I know they're going to add up to 180. So I'm going to do 180, take away 124, which leaves me with 56 degrees. Okay, so that will be 56 degrees. So I know A is equal to, because this is A, that's 56 degrees, so that's 56 degrees. A is equal to 56 degrees, B is equal to 56 degrees, and C is equal to 124 degrees. Okay, so you're just essentially using your laws now, and you'll start using them together. Okay, number 2 states a diagram shows a rectangle, calculate angle D. Oh, this one's like super easy, isn't it? So they've not told me that angle, but it's a rectangle, so I know that's going to be 90 degrees. This is 62 degrees. I know angles in a triangle add up to 180. So for this one, I would just do 180, take away 90, take away 62 equals, all the degrees in, equals 28 degrees. So D equals 28 degrees. Make sense? Okay, so you're just essentially using the rules that you already know to try and fill in these questions over there. So what I'm going to do in the Google Classroom is I will pop this worksheet on. I will also pop on the white rose maths worksheets as well. So if you, which depending on this type of style you want, it will be there. So I'll pop this one on, I'll pop on the white rose ones. I'll also pop on a challenge one. So you can just look and work through as you want. In regards to the white rose ones, if you are looking into completing the challenge work, when you're looking at white rose, just make sure you're comfortable with like questions 7, 8, 9. And as long as you're comfortable with them, just move on to the challenge questions. It should be fine. And I will release the answers before the end of the lesson as well. Okay, so if you just want to work through this question or the white rose ones or whichever ones you are doing, and then give me any feedback or ask me anything if you feel that you still don't understand, and then we can see what we can do from there. Okay, enjoy the rest of your day. Please keep looking after yourselves, and virtually see you next lesson. Okay, take care. Bye bye.